Alright, so today we officially start using the quadratic formula to solve the quadratic equations. Some of you will really appreciate having a formula. It takes some of the guesswork out of the other processes, but you do need to practice it. I'm going to head to page 229 and look at the formula right now. Everybody's good. And here it is. I'm pretty sure I showed this yesterday, right? Fifth period. I pulled this up yesterday. Maybe I didn't. Okay. So this is page 229. And this is the quadratic formula. It's interesting how it says, recall the quadratic formula. Who remembers? Let's see a thumbs up if you remember seeing this in geometry. Let's see a thumbs up if you remember seeing it in Algebra 1. Okay, so to be honest with you, it really depends on the rigor of your classes. Some Algebra 1 classes maybe looked at this for like a day or two and moved on, and some may have spent more time on it. Same thing with geometry. So some of you are more familiar with it than others. Now, I don't think any of you have ever figured out where it came from. So part of your Algebra 2 curriculum is to figure out how was the quadratic formula created. It says, show how to derive this formula. So where did it come from? It came from completing the square. So I have a really big challenge for you guys. It is a part of your curriculum. We are going to start with a standard form quadratic without any numbers. We don't have any numbers. We're going to solve this for x using completing the square. And when we're done, we're going to arrive at the quadratic formula. Okay, so we're going to see how the mathematicians came up with this wild-looking formula. The completing the square process, this method existed before the formula. And then they figured out there was this pattern at the end, and that if people just recognized the pattern and plugged in, then they could skip the whole process. Okay? So right now, we're going to see how the formula was created. For some of you, you'll hang in there until you get about halfway, and then you're going to say, no way, I hate this, I'm not writing anymore, and that's okay. Hang in there halfway. Some of you will make it the whole way. Let's go. We're going to create the quadratic formula right now.
Is this just practice? Or is this like actual?
So, to answer your question, if you only ever want to do exactly what's on a test, this will not be a test question. Okay? It's pretty challenging for a test. It's more like a proof in a true honors pre-calculus class. You might have to prove the quadratic formula. So this is not a test question. This is a challenge question. This is an honors level, higher level type Algebra 2 question. Okay? What we're going to do is the whole process of completing the square without any numbers. We're just using letters. Okay? Let's get started. Now, this has the leading coefficient of A. When we had problems with like a 2 here, the very first step was to divide both sides by that 2. So I'm going to divide everything by A. And then I get x squared plus b over ax plus c over a equals 0. What's the next step, Kevin, in completing the square? First, I divided by that number there. And then what do I do?
You have to find the b value, so b over a, divide by 2, and then square that.
Okay, we are going to do that. First, we'll move c, and then we'll do b over 2 squared. Yes, exactly right. So let's move c to the other side. That's always our first step. It looks like c over a, but that's just because we had to divide and we don't have numbers. So we have x squared plus b over ax plus big blank space negative c over a plus big blank space. And we'll fill in the big blank space using the formula b over 2 squared, like we've been practicing. Now this time, it'll be b over a all over 2 squared. So our b value is this funky fraction, so b over 2 squared. We typically don't do a fraction and a fraction, so I'm going to look at this as like a horizontal division problem. So this is b over a divided by 2. And then this is a keep, change, flip situation, or multiply by the reciprocal, right? So that would be b over a times 1 over 2 squared. And so that's b over 2a squared. And I can square that. Square the top and square the bottom. And that's b squared over 4a squared. So this is the value that completes the square. Let's write it in. All right, we did it. We completed the square. I think the next step was always to combine like terms here and rewrite. So I need to rewrite my problem, and this is supposed to combine. So I'm going to go ahead and combine these like terms. I'll need a common denominator. In January, we will spend a couple of weeks adding complicated fractions with variables and denominators. We'll get common denominators in situations like this. I'll tell you right now, the common denominator between a and 4a squared is 4a squared. So I have to multiply, to make this denominator into 4a squared, I'd have to multiply the top and bottom by 4a. So that is now negative 4ac. The b squared remains. So now that I have a common denominator, I can write it out as one fraction. It's negative 4ac plus b squared over 4a squared. Go ahead. Oh, you're good? Okay. We're pretty close to the quadratic formula already. I can start to see it appear. I'm starting to see familiar parts. Aiden, what's our next step in completing a square? So far we moved C. We put in a new C. What do you do next? Yep, you're gonna factor it. So let's do it. How do I factor this? It should be parentheses. There's an x. There's an exponent. What do I typically put in the factored here? It's this value square rooted that goes in here. So I have to square root the new c. Right. A lot of you guys picked up on this pattern that the number that was going in the parentheses was always showing up in the step before it. So I can square root this. The square root of b squared is just b, and the square root of 4 squared is just 2a. All right. Eric, what was the next step after we factored? Square root both sides. Great big old radical bar. Great big old radical bar. X plus b over 2a equals plus or minus. Whoa, we're really close now. And then the last thing we did was to get x alone, we would add or subtract whatever value is here. So I'm going to subtract b over 2a. And then we always put that value in between the equal and the plus or minus. And that is the quadratic formula. There's what is the bottom though of the quadratic formula? What's the denominator supposed to be? It's supposed to be 2a, right? And I have this. So how do I go from this to 2a? I can square root the top and bottom separately. So I'm going to simplify the radical, which is exactly what we did with completing the square. We would stop and simplify our radical. So I'm going to look at this as the top square root separate from the bottom square root. So the square root of 4a squared is just 2a. The square root of 4 is 2. A squared is a. I'm also going to put this bit in standard form, which means the b squared would be first. There's b squared minus 4ac. All right. Negative b plus and minus the square root. B squared minus 4ac over 2a. And our very last step is, it's kind of wild. These happen to be common denominators. Does anybody recognize this from anywhere? X equals negative b over 2a. Yep. This is the formula for the axis of symmetry. So there's actually a lot of symmetry going on here. So this is negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's the quadratic formula. Now you know. Yeah.
If that's the axis of symmetry right there, why don't you just do opposite of 0 to 2a for the vertex and put it in? I mean, to get the axis of symmetry, put it in.
That's what we always do.
That's what I was supposed to show you. I was showing you 0 as not the vertex.
Yeah. Yeah, we're fine.
So it's the vertex plus or minus.
It's the very center. It's the midpoint. It's the x value. All right. Anyway, you guys. So you can think historically now. Back in history, completing the square, they saw the pattern of the answers. They said, "Hey, there's always a plus or minus sign. The denominator is always double A. There's always this pattern underneath the radical bar. Let's skip the whole process and just tell people what the answer will look like. The answer will look like the negative b value, the plus or minus, the radical, these values, and double A on the bottom. So now we know. We don't have to do the whole process. We can plug it right in there. Yeah. Yeah. Let's do it. Let's take those numbers and fill them in. It is a little too. It actually is too good to be true. It's way harder than it sounds. All right, guys, go to page 232 and let's do a problem. All right, guys, if you know you like to use calculators, get that calculator out. This is a calculator moment. So you don't have to do what we just did. You don't have to create the quadratic formula on a test, but you do have to use the quadratic formula and you have to memorize it. On the algebra one EOC, they give it to you. On the geometry EOC, they give it to you, but you need to memorize it on your algebra 2 test. There's so I have to ask the ACE math teacher if it's on the ACE math exam. And then I'll have to check the new digital SAT to see if they give you this formula. If both the ACE math exam and the digital SAT give you the formula, I'll give it to you on your test. Okay. I'll just have to check that. Maybe you guys can check it too. But I'd like to know that they keep throwing more and more formulas on the test. So. Alright, so I just want to walk through one of these to give you some tips and tricks on how to simplify it correctly. So I'm going to start with x equals, because I'm finding x-intercepts, I got negative b, and the b is already negative, so that will end up going positive. Plus and minus sign. This is another way to solve an equation, just like factoring, just like completing the square. This is the last way that we cover solving, and some students like it the best. So minus 4 times 1 times 4 all over 2 times 1. So when you plug in correctly, there's no more letters. I just have numbers here. So all you have to do from here is really utilize PEMDAS, the order of operations, correctly. So so you're aware, in your calculator, don't put the radical. But if you want to put all of this in your calculator in one step, that's the most difficult part to get right. So you can practice that. I'll show you the order to do it by hand. Exponents typically come first. So first I'll do the exponent, and I'll also deal with this negative negative and make it a positive. So I got 36. The biggest thing is don't do subtraction till the end. So this multiplication comes before subtraction. So I'm going to take it one step at a time and just do like that 4 times 1. Yeah, so there's a negative in the formula, and the b value is negative, and they cancel each other out. So the two negatives go positive over there. Okay, now I will do 4 times 4, and I end up with 36 minus 16. And then I can finally do the subtraction. Do the subtraction last. Do all of the multiplication first. Subtract last. A lot of students will stop here, but there's always some tricky simplifying that has to go on until you're really done. The square root of 20, I know, is square root of 4 times 5. I have to put it in simplest radical form. So I'm going to simplify square root of 20 to 2 square root of 5. I'm going from here to here. Yeah, so I can write all the perfect squares. It's dividing this number by numbers that do square root. Okay, and then a lot of students will stop here, but you can actually keep going. I'm going to go 6 over 2 plus or minus 2 square root 5 over 2. And 6 over 2 is 3. And the 2 over 2 can cancel. This is the final answer. So it's so common that students stop this problem early that I've decided to put the assignment on Big Ideas Math because if you don't have it finished all the way, you won't see the answer show up. And there's unlimited checks in Big Ideas Math, so put it in, check it, put it in, check it as many times as you want. But ask questions as you go and figure it out. This is your final answer. Yes.
So if it is like, if you can square whatever, square root it and then divide it.
Yeah. If it was like a 4 or something. All right, so these can really vary. So it's important you practice all 6 questions in Big Ideas Math. We have not been on Big Ideas Math other than test remediation, so this is good practice. It's 3.4, numbers 1 through 6. Some of you may have done it yesterday because it was posted yesterday. If you did, I'm gonna put a GIM kit up for you guys to do. But no rush. I have number 1 ready to show you. Number 2, I want you to take your time and go through these questions and ask how to do it. Okay, Reagan.